Okay, what we're going to do here is we're going to learn how to use the standard normal table backwards. And to start out here, we're going to play a little game. This game is called What Z-Score Am I Thinking Of? So what I did is I thought of a Z-score and I put it down here where I thought it would be. And I shaded the area below, and then I looked the Z-score up on the table, and this is the area that I found. So what I want you to do is, can you tell me what Z-score I thought of? Okay? Maybe grab your table and see if you can figure out from this information which Z-score I thought of. So you can pause the video if you want, and then see if you can find the Z-score. Okay, so let's see this. Check and see if this is what you did here. When you look for the Z-score, what you're doing is you're looking for this area here in the table, because normally you look up the Z-score and find the area. So I'm going to look for 0418 in this table, and I'm looking on the negative side of the table. Okay, so 0418, and I'm going to try to find it. And there it is. And so then what I do is I look down here, I look over here, and I see negative 1.7, and I look up here, 0.03. So it'd be negative 1.73. So let me show you kind of what is going on here. So I'm looking through this part of the table, looking for this, and then I eventually find it, right? Okay, and then to know what Z-score gave me that area, I would look back over here, and it's like negative 1.7, and I look up here, and it's 0.03, and then I put these together, and I get negative 1.73. And that would have been the Z-score that I thought of, looked up on the table, and found that area. So let's play the game one more time. So in this case, I looked up a Z-score and kind of marked where it would be, shaded the area below, and this is the area below. So see if you can find the Z-score that I'm thinking of. You can pause the video if you want. Okay, so now let's see if you got it here. First of all, notice that this is on the right side of 0, and this area here is more than 50%. Below 0 is 50%, so that's more than 50%. So I need to look on the positive side of the table, right? I need to look in here, and I'm looking for 0.6736. So I'm looking, and I find it. It's right here, 0.6736. I go over here, and I find 0.4, and then I look up, and I find 0.05, and I can put those together. So again, let me show you what happened here. So I'm looking through here, I'm looking for this, and I find 0.6736 on my table, and then I have to look over here, and I find 0.4, and I look up here, and I find 0.05, and then I put those together, and I get 0.45. And that would be the Z-score I'm thinking of. Okay, so this is the basic idea, and you can see now why I call this using the table backwards, right? Because normally you're given this Z-score, and you look up the 0.4, the 0.05, where these two cross, you get this area. So you're just doing the whole procedure backwards. Okay, so now we're going to make this just a little harder. What I'm going to do here is I'm going to have some numbers that are not necessarily on the table. Okay, it'll be an area, and what I want is some Z-score that gives me this area below it. And of course, the numbers on the table, there's gaps between them on this table. Okay, so what I'm going to do is I'm going to find this number. I'm going to get as close to that as I can on my table. So I'm going to look through here, this case on the negative side, until I find the number that comes closest to that. And then what that'll give me is it'll give me the z-score to the nearest hundredths place is what it'll give me. That gives me this area. So let's see what I can find. So I go on the negative side of the table and I'm looking for the one that comes closest, 1.7, and then I see 0.1736, and that is very close to this. It's off by just 1/10,000th. And so I go over here, I have a negative 0.9, up here 0.04. Okay, so let me show you. What I did is I looked through here and I found 0.1736, and this was the number that came closest to this on my table. So I looked over here and I have negative 0.9, and I look up here and I have 0.04, and so this was negative 0.94. Okay, now let's say I have one like this where the area here is now above the z-score, and so what I want is I would like the z-score that gives me this area, 0.0325. It has that area above this z-score. Okay, so now think about the way that you found the area above. If you have the z-score, you look that up on the table, and that will give you this area over here. Then you have to subtract from 1 to get this area, right? And so you got to reverse that. You got to subtract from 1 to get this area, and then you look this area up on the table. Okay, and this makes sense because when you actually look up a z-score, it doesn't give you the area here. It gives you the area on this side. So I need to look up the area on that side. Okay, so I'll take 1 minus 0.0325 here, and then I get what is this, like 9, and I just want to make sure I get the right number here. 1 minus 0.0325. 1 minus 0.0325. So 0.9675. So this is the number that I'm looking up on my table, 0.9675. And I'm looking that up on the positive side, 0.9675. And you see I got like 0.9671, 0.9678. So the 1 is kind of like 4 away, the 8 is only 3 away. So the one that comes closest as I look through here is 0.9678. The other one over here is like 0.9671. Okay, so this is actually the one that comes closest to this. So I'm looking over here, I'm looking up there. So 0.9678, this is 1.8, 0.05. So this is 1.8, up here is 0.05, so I get 1.85. And that would be the z-score to the closest hundredths place. That gives me this area above it. So you can kind of compare this one to like case 1 when you find the probability, where you look up the z-score and the area on the table is your answer. Okay, and you can compare this to case 2, where you look up the z-score, get this, have to subtract from 1 to get this, and here you're just doing it backwards. You have this, subtract from 1 to get that, and then look it up backwards to get that. So this kind of does case 1 backwards, this is doing case 2 backwards. Okay, now let me do one here, and what you're going to find with this one, 0.0388, and that's actually the area below, so that's what I want to look up on the negative side. And what you're going to find is that this one falls halfway between two values. So I'm looking up 0.0388, and here I got 0.0392 and 0.0384. So I'm looking through here, there's like a 0.0392, 0.0384. And if you notice, this one is like halfway between these. Like 88 compared to 92, that's 4 away. And 88 compared to 84 is 4 away. So it's halfway between these two. Okay. So like over here, this is negative 1.7. Let me look here. And then the other, these two up here, this one is like 0.06 and this one is 0.07. And so since this is halfway between those, the question is, which one am I going to go with? Which one do you use? And the answer is, I'm going to actually go with this one. I'm going to use negative 1.77 instead of negative 1.76. And the reason I'm doing that is I'm always going to choose the one that's further away from 0. The one that lies further out. Okay? So on this side it'll be the one that lies further out. And there's a reason for that. When we actually use this stuff to determine rejection regions, this is just going to make the test more conservative instead of less conservative. By going out, that makes that increases the significance level instead of decreases it. So don't worry about that. There's a reason you do that, and the point is you're just kind of, in a sense, you're rounding out or you're rounding up. I went up. It was halfway between. I went up to 0.07 instead of 0.06. Okay, so that's what you do when it's halfway between. Okay, so now here's some of the problems. You might have some problems that look like this. And what they're going to have here is they're going to have percentages, and they'll ask questions like this. Maybe like something that says, below what z-score is the bottom 23.5% of the area? So what I would do with these is I would draw a picture. Okay, put 0 in the center. And then, you know, it doesn't have to be perfect, but kind of make it realistic. You're talking about like 23% of the area, so that's quite a bit of this area. And you want to know what z-score gives you this bottom 23.5% of the area. So what you're going to do is you're going to change this to a 4-digit decimal number. So that means you move the decimal point over 2 places. Okay? And then what you should do is you should add a 0 so you have a 4-digit decimal number. That way it's easy to look up on the table. So you make that into a 4-digit decimal number, and this is the area below, so I just need to look that up on the negative side, whichever one comes closest. So 2350, 2350. So here's 2327, 2358. So this one's 8 away. This one is like a lot further than that. So this is the one that comes closest, and that's negative 0.7. Up here is 0.02. So the z-score would be negative 0.72. Okay? So that would be the z-score that gives you the bottom 23.5% of the area. So let's try another one. This says, above what z-score is the top 6.45% of the area. Okay, so let's draw a picture of this. So what you're going to do is you're now talking about the top area, and you want above a z-score. And so, I don't know, about 6.5% of the area might be something like this. So this area here is like, not 6.5, sorry, 6.45% of the area. Okay? And you want the z-score that has this area above it. Okay, so this is the one where you have to subtract from 1. And so maybe I'll change this to a 4-digit decimal number. So there we go. It'd be 0.0645. And then what I want to look up is this area. The table gives me the area below, so I want to look up the area below. So I'm going to subtract that from 1. So 1 minus 0.0645, and I get 0.9355. So whatever z-score comes closest to that, that's on the positive side, of course. So 0.9355. So I'm looking through here. There's 0.9345 and 9357. So this one's 5 away. Oh, no. Wait. 5. So it would be this one, the 0.9357. That's only 2 away. So that's 1. I go out here 1.5, and then up above is 2. So 1.52. So this would be 1.52, and that would give me the top 6.45% of the area. Okay, and then one of the other problems would look like this. This is almost one of the most important problems because this is one of the things you use in inferential statistics, as we will see when we get to chapters 7 and 8. It says, between what two z-scores do you get the middle 77% of the area? Okay, so what do I mean here? Well, 0 is in the center, and so I want two z-scores, okay, the same distance away from 0. So this one will be a negative z-score, this one will be a positive z-score, and they'll be the same number. It's just this one is negative, that one's positive, and in between these two, you actually have the middle 77% of the area. Okay? So, how do you do this? Well, what you're going to do is you're going to find out how much area is in that lower tail. And so you're going to take 100% minus the 77%. And when you do that, you get 23%. And so this 23% is going to go in the two tails. Okay, so all of it doesn't go into one tail. You have to divide that evenly between the two tails. Okay, because the curve is symmetrical. It's the same on both sides. Okay, so 23% divided by 2. And that's like 11.5%. So that means this down here is 11.5%. And this over here is 11.5%. And so basically you add all three of those, you get the full 100%. So you're just finding the amount of area in the tails. And let me just, I'm going to say one thing real quick. When we get to chapters 7 and 8, this area here is going to be known as alpha. And this is actually alpha over 2. Alpha is actually known as the significance level of a test. Okay, and it'll be as, you'll write it like a decimal. And then this would be like 0.115. It'll be a decimal number. But this would be alpha, and this would be alpha over 2. You'll see those when we get to chapters 7 and 8. Don't worry about it now, but it is something that you'll see later on. So, and if you're wondering where these are coming from, this is actually where it's coming from. Okay, so let's finish this out. I need to make this into a 4-digit decimal number. So I get 0.1150. And I'm going to look this up on the negative side of the table. Okay, so look up over here. And, I see 0.1151. That one comes the closest, and that corresponds to negative 1.2. Up here is 0. So this is negative 1.20. And so this one over here is positive 1.20. And so between what two z-scores is the middle 77% of the area? Between negative 1.20 and positive 1.20. Okay, and that's how that is done. Just one other thing. Well, let me just leave it there. I think that's good. So that's how you use the standard normal table backwards.